All right, here we are, number 1 on review number 4. Okay, so it says we got a normal distribution, we've got a mean of 28.3 and a variance of 4.5. Find the probability that a random chosen value of x lies between 25 and 30. So our x is between 25 and 30. We got to find the probability of that. And if we take a look at the curve, our normal distribution, well, the 28.3 obviously will be the mean, and then 25 will be on one side and 30 will be on the other. It's not equal distant from the mean, because then we could just figure out one of them and double it, so we're going to have to do both. So first thing we got to do is we got to change these to z-scores. We can do them one at a time. We got 25 minus 28.3 all divided by the square root of 4.5. And then we'll do the other one. We'll do 30 minus 28.3 all divided by square root of 4.5. And that'll give us two z-scores. One will be negative and one will be positive. We expect that because when we convert it to a standard z-score, the mean's going to be 0. And so anything below the mean would have been negative, and anything above the mean will be positive. So now we've just changed these, and these are now our new numbers, z's. And the mean is going to be 0. So now, how are we going to find the probability? Well, our table only goes one direction. My table only goes to the right. Now, obviously, I can take the z-score of 0.8014, and I can find everything to the right of it. Now, the problem is that's too much, but that is a lot of what I need. So let's start with that. Now, the thing is, I got to get rid of that little tail part at the end. Now, the problem I have is that I can't do the 25 because it's a negative. So instead of doing negative 1.556, I'm going to do positive 1.556. The problem is, again, my table is only going to go less than that. So what I'm going to do is I'm going to have to find the probability that's less than that and then take that away from 1 to get that little piece at the end. So anyway, I just kind of map out what I'm about to do, and then I go to the table and I look for my z-scores. And just being careful about this, and I find the probability for the first one, and then I find the probability for the second one. And then all I got to do is simplify this, and I'll find out the probability is going to be 0.729, 3 significant figures. All right, number 2, Maria's got 3 preset stations on a radio. When she switches the radio on, there's a probability of 0.3. It'll be set to station 1. Probability of 0.45, it'll be set to station 2. And a probability of 0.25, it'll be set to station 3. All right, now you notice it seems like we're looking at a probability tree here because we've got choices, and then they're giving us the probability of each one of those choices. Let's take a look and see what we've got. Okay, so let's kind of mail this out. We've got the probability of station 1, 0.3, and station 2, 0.45, and station 3 is 0.25. And you know, if we add those up, we get 1.0. That means they're the only possibilities. And so now let's take a look at the other information. Probability of male, 0.1 for station 1, and probability of male is 0.85 for station 2. Probability of male is P. We don't know that now. They tell us it's going to be 0.3. We got to prove it. We got to show that. Now, the additional information they give us in order to prove it is that the probability of it being station 3 and being a male person on the radio is 0.075. So that's a probability that's going to be at the end of the tree, and we'll have to work it backwards. So let's go ahead and map out our tree. We've got 3 forks in the first one. Remember, at the end of each fork, you put down what could have been, station 1, 2, or 3, and then on the lines, you put down the probabilities for each one. And so now, for each station, we've got the choice of male or female. And they gave us the probabilities for the male, so then we know the probability for the female. And all we got to do is fill in the information and all the way down. And once we've got that, we've got to take a look at the information they gave us and we're looking at station 3 and male. Now they're telling us that if it's station 3 and male, we know the probability. So that's 0.25 times p, and we know that's going to equal 0.075. Well, all we got to do is divide both sides by 0.25, and we're going to find out that p is 0.3, which they told us, and we proved it. All right, now, what can we do for part 2? Part 2, it says, given Maria switches, again, we got a conditional probability here, switches probability the radio is on station 2. So what's the probability that's on station 2 given that she hears a male? Now remember, when we got conditional probability, we got to find the probability of both things happening and divide it by the probability of the given thing happening. In this case, we got to find the probability of it being station 2 and hearing a male. So we go down to our tree. We go along station 2, we see 0.45 and male 0.85. We multiply those together, and that's the probability of both things happening. Now, the probability of it being male, well, there's 3 different chances for that. We could do 0.3 times 0.1, that's in the station 1. And we could do 0.45 times 0.85, that's station 2. And we already know the probability of it being a male in station 3, that's 0.075, so we can just add that last one. So all we got to do now is simplify the numerator and the denominator and divide. And we're going to find out that the probability is 0.785. All right, now in 3, we got a spinner. It's got 5 sides, 1, 2, 3, 4, 5. And when they spin it, then that's our random variable x. And they tell us the probability distribution. And so we've got all of our choices, 1, 2, 3, 4, 5. We don't have all the probabilities. They want us to find a p. So one thing we know about a probability distribution is when we add up all the probabilities, it has to add up to 1. So all we've got to do is add up these and then simplify. And we're going to find out that the probability that p is actually 0.1. And then we can figure out the other probabilities. So we got 0.1, and then we'll put that'll be 3 times 0.1 and 2 times 0.1. All right, so let's take a look at part 2 now. In part 2, it says we've got a second spinner, and it's got 3 sides, 1, 2, and 3. And they also give us the probabilities of each one of those things happening. Though they didn't give it to us in a table, we could write one if we want to. I mean, because again, we just got 3 choices. Let's go ahead and do that. So we've got y in this case, 1, 2, 3, and the probability of y being y, well, for 1, we know it's going to be 0.3 and 0.5 for 2, and then 0.2 for 3. All right, and again, you check them quickly. They add up to 1. That's good. All right, and we got all information in front of us. Now they want to know the probability of the sums being 4 if we spin both. All right, so if we spin the first one, we spin x, and a 1 comes up. Well, the only number that can possibly work to give us a 4 is if y is a 3. The probability of that happening is 0.3 times 0.2. If I spin x and I get a 2, well, the only number that y can give me that will give me 4 is another 2. So I can multiply those probabilities together. And then if x is a 3, well, then the only thing I can get is a 1 on the y spinner, and that's 0.3 times 0.3. And if my x gives me anything else, a 4 or a 5, well, then the sum cannot possibly be 4. So these are my only chances. I add them up, and the probability is 0.225. Now, in the second part, they want to know the probability of a product being less than 8. So we're going to do a similar kind of thing, only we're going to do a little bit more of it. So again, if the spinner x spins a 1, well, 1 times any 1, 2, or 3 are going to give me a good number. So 0.3 times 1 is going to be 0.3. And then 2, again, any number for the second spinner is going to work. And again, to clarify that, I mean, think about it. If the spinner number 1 or spinner x gets a 1, well, then it really doesn't make a difference what spinner y is, because 1 times 1 or 1 times 2 or 1 times 3, they're all going to be less than 8. So the probability of me getting a number for spinner y is 1. So that's why I'm multiplying 0.3 times 1. And then the same thing when I get a 2 on x, the spinner x. Well, now, again, any number will work because if I multiply 2 times 1 or 2 times 2 or 2 times 3, it's still going to be less than 8. So again, the probability of getting a 2 is 0.15 on spinner x, but the probability of getting any number at all is 1. So that's why I multiply those together and get 0.15. Now for 3, well, now I got some difficulties. I can get a 1 and I can get a 2, but that's the only thing I can get on spinner y. So that's 0.3 times 0.3, and then I also can get 0.3 times 0.5. Now keep in mind that's the same thing as multiplying 0.3 times 0.8. Anyway, we got 0.24 for that one. And now if x gets a 4, well, now the only number that can come up is a 1, because if a 2 comes up, well, it's going to be 8, and that's going to be not less than 8. So then I've got all my chances. If a 5 comes up, then I only can get a 1. And again, the probability is going to be for that. And now all I got to do is I figured out the probabilities of each one of those things happening. All I got to do is add them all up, and I get 0.765. Now for 4, we got a mountainous region in the winter. The probability of more than 20 centimeters of snow falling on any particular day is 0.21. Find the probability in any 7-day period in the winter that fewer than 5 days have less than 20 centimeters of snow falling. So we've got some trials. We've only got 2 outcomes. Is this a binomial distribution? We've got an independent probability of success. The question is whether it snowed more than 20 centimeters or not. It seems like we do. So the probability of 1, 2, 3, or 4 days having more snow than 20 centimeters. And again, it's yes or no. So instead of doing 1, 2, 3, and 4, I'm going to find the probability of 5, 6, and 7, and then subtract that from 1. So anyway, you use the combinations. It would be 7 combination 5 times the probability of success to the 5th power, and that probability of failure to the 2nd power. And then I'm going to repeat this with x equals 6. It'll be 7 combination 6 times probability of success to the 6th, and then probability of failure to the 1st. And then one more time, I'm going to do the probability of it being 7. And I'm going to follow the same kind of program. And then all I'm going to do is add these up and subtract their total from 1. And that'll actually be the probability of 1, 2, 3, or 4 days of having greater than 20 centimeters of snow. So I could have done 1, 2, 3, and 4. This was one less step. Looked a little bit easier. Now for part 2, they say 4 randomly chosen 7-day periods in winter. Find a probability that exactly 3 of those periods will have at least 1 more than 20 centimeters of snow falling. So again, now we got 4 trials. They're different. They want to know about the probability of a week having at least 1 day. The probability of success, they didn't hand it to us. We have to figure it out. So if I find the probability of 0 days having at least 20 centimeters and then subtract that from 1, well, that's going to be the probability of at least 1 day having more than 20 centimeters. So then all I do is do the combinations like I did before, and I find out the probability of having at least 1 day in a week is 0.808. So now I've got a probability of success. 0.808 is the probability of at least 1 day having snow more than 20 centimeters. So now I've got 4 trials. So I do the same kind of thing I'm doing, only I'm looking for it to be x equals 3. So 4 combination 3, probability of success is 0.808 to the 3rd, probability of failure 0.192 to the 1st. All I got to do is multiply that out, and I found the probability is 0.405.